Hi, this is a lesson on circles, specifically arcs and arc length. So let's talk about arcs. So arcs is a new word for us. We have not talked about this before. An arc is part of a circle. So it's a distance or a curve that is not a full circle. It is just a piece of it. So any 2 points, A and B on a circle, determine an arc. So you can use AB with a little curve above it, and it will describe an arc, a curve, if you will, around part of the circle. Now, if you want to go the long way, notice I went the short distance. If I want to go the long way around, and I want the reader to know that I'm going the long way around, you can use 3 letters. So you can say A, D, B. But the psychology behind it is we tend to go the shortest distance. So if I say AB, everyone's going to probably go the short way. So 2 letters is going to be, as a default, the shortest distance. But if you want people to talk about the larger arc, you're going to need to use 3 letters. So those 3 letters need to sort of draw out or lead you down a path to get this down. Now, the small arcs are called minor arcs, whereas the larger curves, when I say large, I'm going to give you an actual number here. The large arcs are major arcs. Okay. A minor arc is smaller than 90. Okay, it's less than 90 degrees. Sorry, not 90 degrees, 180. Less than half of a circle, okay? 180 degrees is half a circle, so less than that, it's going to be considered minor. Whereas if you want them to go the long way, over halfway around the circle, you're going to need to do a number or an angle that's bigger than 180. Now, notice, I'm talking about angles when I'm talking about these. I'm not talking about circumference right now. I'm not talking about like distances. I'm just using an angle to illustrate the piece of the pie, if you will, the crust around the pizza. How much is it? Using 30 degrees or 60 degrees or 90 degrees is a very easy way for us to describe how large an arc is without actually getting into the minutia of length. Okay, so determining the measure of an arc, we are going to use degrees. Okay, we're going to use degrees to do measures of arcs. So let's talk about this. How are we going to figure out these degrees? Well, the measure of a minor arc and a major arc depend on the intercepted. Oh, sorry, not I'm using the word in the wrong place. Depend on the central angle. Sorry, central angle of the intercepted arc. So what the heck am I writing here? I do know what I'm talking about. I'm just having problems drawing with my finger here. Intercepted, oh my goodness, arc. Having a good time here. All right, so what does that mean? Well, if this is the angle, that's called a central angle. And the reason why it's called the center is because it's in the center. That makes perfect sense, doesn't it? So and think about that as being almost like a flashlight shining out towards the edge of the circle. Well, that's the arc that got intercepted by that flashlight, okay? The measure of a minor arc is the measure of the central angle, okay? The measure of a major arc is the difference of 360 and the measure of the related minor arc. What the heck does that mean? That means that if you want to figure out how big this is, what you're going to do is you're going to take 360 and subtract 80. And you're going to get 280 degrees. That is the size of that major arc. Okay? Now, a semicircle is a special case. Semicircle is arc with central angle measures at exactly 180 degrees. Okay? You're going to use 3 points for this. The reason why you're going to use 3 points is, let's say I've got a central angle here, and I've got a semicircle. If I want you to visually look at that circle and know that I'm talking about the top half of the circle, I need to use 3 points to guide you. So I would say A, B, C to make sure you go towards the top versus the bottom half. Okay? So 3 letters is, again, going to let us identify and communicate with each other. So looking at these examples here, let's look at this first one. The minor arc and major arc in this picture, let's color them. The major arc is going to be the large arc. The minor arc is going to be the small one. The major arc is D, G, F, as an example, with an arc above it. And the minor arc would be D, F. You could have the letters in a different order if you want to go a different direction on it, but again, that G better be in the middle of those 3 letters. The measure of the minor arc, that seems like the easier one to do right now, is 40 degrees. To figure out this measure, the major arc measure, I have to take 360 and subtract 40. 320 degrees is the major arc, okay? So looking at this one, this would be one you would try. So if you want to pause the video and then try this out and then check your answers, go ahead. I'm going to write the answers right now. The major arc would be NML. The minor arc would be LN or NL. The minor arc is 110 degrees. The major arc would be 360 minus 110 or 250 degrees. All right. Going on, we can make the pictures more complicated. So let's say I want to figure out the measure of GEF. Notice I'm drawing on my circle. Well, it actually works out pretty darn easy. If you add up the central angles, that's supposed to be 110, add up the central angles and you'll actually get the total arc. So it's not supposed to be difficult. It's just weird because we're talking about something brand new. If I add those 3 things up, let's see, what is that, 120, 110, that's 230 degrees. That's how big that is. So looking at this, if I want to find BC, that's 58. If I want to find EF, that's also 58. What a coincidence. Those are vertical angles. Vertical central angles, I should say. And then they have equal arcs. That's sort of interesting. If I have DE would be an unknown. Ooh, a mystery. Okay. And CD, we have 72. So let's talk about this. All right, so let's erase all this. DE is this arc right here. I'm going to help you out. Look at this line. Look at all of these angles. What do those add up to? That's right, they add up to 180. So if you take 180 and you subtract the 72 and you subtract the 58, or let's make this 108 minus 58, you'll get 50 degrees. That is what's left. That is DE. Okay, you get the idea? So let's talk about these. These are major arcs. If I have a BFE, let's B, then I go to F, then I go to E, I would add those 3 up. That'd be 158 degrees. If I want to figure out what CBF is, CBF, I would add those up. Oh my gosh, that's another 158 degrees. That's interesting. Okay. Looking at this one, finding the measure of OMA. OMA, how big is that angle? That's right, 60 degrees. Okay. If I want to figure out EMU, figure out this angle. It's a little bit more complicated. Maybe this will help. That's the diameter. And now you've got 2 angles over here. That's right. They add up to 180. So this has got to be 110 degrees. And find the length of AO. Whoa. What are we talking about? Find the length of AO. Find the length of this? Well, wait. We have not done this. This is new. We haven't done this. Hold on a second. This is something completely different. Well, let's talk about it. This is called the arc length. So let's talk about things we know. We know that the radius is 6 centimeters in this picture. We could figure out the circumference, like the total, and we've got the 60-degree angle. All right. Somehow we need to take that information and make it into something that's going to give us the answer. So let's talk about the circumference. So the circumference is 2r times pi. We'll leave it in terms of pi like we've done in the past. So this is going to be 6 times 2, or 12 pi. So that is the circumference. But we don't want the full circumference. We only want a slice or a fraction of the circumference. So another way to think of it is we want the fraction of 60 out of 360 of that circumference. That is going to give us our length. I don't like using the L. The arc length for this problem. Okay? Now, I do not have a calculator with me right now, so I'm going to do some mental math. So 60 and 360, that's 1/6 times 12 pi. 12 and 6 simplify, so that's 2 pi. And that is your slice or your fraction of the total circumference. And that would be the length of AO. So it's actual number. So instead of giving you degrees, whatever 2 times 3.14159 is, that's how many centimeters the length of that arc would be. If you actually had to buy some trim or something and bend it around the circle, that's how much trim you'd have to purchase at the store. So I'm going to skip through some of these just because they're repetitive. These are all examples of angles and angle things. Notice we have an M here, M, M, M. They're talking about the measure. And remember, measure is degrees. Okay? Measure is degrees. Whereas when we talk about arc length, in a circle, measure of the length of a given arc to the circumference. Oh, I think I misspelled circumference, because I think they really meant us to say ratio is equal to the ratio of the arc or central angle of the arc to 360. In other words, the length of the arc is to the circumference as the measure of the arc is 360. So that's sort of what I'm talking about. It's the symbolism. So notice, arc length of AB. There is no symbol. You have to write this out. It's written. Okay? It's written. We're not going to use a symbol. If I have AB with an M in front of it, this is degrees. If I want the arc length, I've got to write it. You got to actually write the word arc length if you want arc length. Okay? All right. Let's look at a couple quick questions. And I'm not going to do all of these just for the sake of time because this video is getting lengthy here. Let me do one more. So you've got a radius of 5 for a circle. And the central angle of the arc is 60 degrees. So this angle here is 60 degrees. And they want to say, what is the arc length? So how big, how long is this? How long is it? They don't want to know the angle. We already know it's 60 degrees. So you have two ways to do it. So I showed you how to take the 60 out of 360 and multiply it times the circumference. So that's the circumference. So you have to figure out the circumference. So circumference is 2r pi. So 2 times 5 is 10 pi. So if you do this method, you get 1/6 times 10 pi, or that's supposed to be a pi symbol. Sorry about that. 10/6 is 5/3 pi, and that would be your answer. Okay? Now, there's another way to do it. You might not like that. That might be a little confusing to you. So another way you can do it, because some of you really enjoyed when we did similar triangles, you can do a proportion. So 60 and 360 should be the same as 10 pi and our answer that you're trying to figure out. So you could cross multiply these and solve for x, and you'll get 5/3 pi. It'll give you the same answer. I don't care which method you use. I tend to use 60 over 360 times whatever it is, the fraction of the total. You can do that, or you can do the ratio like it's described in the notes.